Hello, my name is Kyle Stevens and I'm an optical engineering major at the University of Arizona, and I was a part of the University of Arizona Angel Microgravity team. Other team members included Nathan Moog, Kevin Newman, Sarah Meshberger, and Sean Gellenbeck. Our experiment dealt with the gravitational effects of liquid lenses of large aperture in the microgravity environment.
Hello, my name is Kevin Newman, and my part of the project was design of the optical lens structures and also for the optical testing. Let me go show you how that works. Alright, so the liquid lens is made up of two different kinds of liquids, and they're both housed within this structure here in two different chambers, if you can see that from the side. And the interface between them forms the liquid lens curvature surface that we're looking for. So in order to test that, we set it up with this experiment here, which uses an LCD screen and a CCD camera with the lens in the middle. So the LCD screen has a bunch of fringes on it that move as a function of time, and we look at what the image of the fringes look like through the lens using the CCD camera, and that tells us about the optical quality of the lens. So once we have all the flight data that we want, we analyze it using the SCOT software, which was developed here at the University of Arizona. And it essentially made this test possible because before this software was developed, we would have to do something kind of complicated like interferometry, which would be really difficult on a moving, vibrating aircraft and would be really difficult to pass all the safety standards. So we input all the images that we took from the flight. The center circular area here is just focused on the actual lensing part of the structure. So we define an aperture around that of the part of the image that we want to analyze, and then we do some phase unwrapping, which will tell us, after some processing, the amount of information that we want to know about the optical quality of the lens.
I'm Nathan, and my part of this project was to develop the electronics that told us what the acceleration due to gravity was during the experiment. We measured gravity in two different ways. One was using a 3-axis accelerometer, and the other was using a force-sensitive resistor attached to a weight. And we collected all the data on an Arduino microcontroller and sent it directly over serial to a laptop which recorded the data. Here's a demonstration of how the force-resistive gravity sensor worked. What this is going to do is it's going to take a reading of resistance from the resistor and then play a note that corresponds to it. By varying the pressure, I can change the note. And basically what this did was this weight sat on the resistor and it gave a number for each weight that was on there and it just recorded it. So when we were in microgravity, the weight was putting on no resistance on the resistor, and we were able to read a 0 for the force of gravity.
Hi, my name is Sean Gellenbeck. For this project, my primary responsibility was to work on the structure that supported our optical rail system, which was attached to our liquid lens. Our structure is made of 1" by 1" square and 8" thick aluminum tubing that is welded together into the structure you see here. The optical rail subsystem, which included the camera, the liquid lens, and the LCD screen, was attached right here inside of our structure.
Our liquid lens did not perform completely as expected, but it did improve in the microgravity environment versus Earth's gravity. In the future, we hope to use what we've learned through the data collection and through the experience to modify our setup to increase the performance in future microgravity flights.
So microgravity was definitely the most unique experience I've ever been a part of. It was for sure the most fun I've ever had throwing up.
So my experience in microgravity was like, excuse me. Okay, no, not entirely like that. My experience in microgravity was a lot of fun. Mainly the transition from hypergravity to zero gravity was really cool because you're laying on the bottom of the aircraft and you feel like you're being sucked into your chest, kind of everything feels really heavy, and all of a sudden you start getting lighter and lighter and lighter, and then all of a sudden you start floating towards the ceiling and everybody around you is floating, and it's an experience like nothing else. It's really cool.
Microgravity was really amazing. I enjoyed it a lot. I got to look out the window and I really can't wait to get to go back.
Everyone that I've talked to about it who is not able to be on the plane is very jealous, and I hope that they all get the opportunity to do an experiment and have the opportunity to fly on this plane like we did.
Microgravity was an awesome experience that I'll never forget. It was really exciting floating in the air and not knowing which direction you were, and being able to do an experiment from start to finish was incredible.